So full stack development with Java and NoSQL. So in particular, being that I work for Couchbase, the NoSQL database in these examples are going to be Couchbase. But Couchbase and all of its products are open source, so you don't have to pay for it. You can download it. It takes a couple minutes to install, and we'll go through this whole process as we go through the slides. First off, I'm Nick Raboy. I actually work out of San Francisco, so I'm here for the day. But I develop it with a variety of technologies. So I use Java, I use Node.js, JavaScript, all over the board with technologies. So and that's what leads me into full stack development. So I'm hoping that everyone gets a lot of value out of the stack that I'm about to show off. Has anyone worked with NoSQL before? What kind of NoSQL databases is everyone using? Mongo. Anyone not using? Anyone not using Mongo? What are you guys using? DynamoDB. DynamoDB? Cassandra. All right, awesome. So since this is many of your guys, I'm assuming, first time hearing of Couchbase? Anyone? Everyone's heard of Couchbase. Awesome. Well, I'll give the overview first, so that way we can get an idea on what kind of database we're going to be working with, and then I'll jump into some code examples, and we'll walk through an example application. So first off, Couchbase is a NoSQL document database. It's also a key value store. It has a managed cache layer to it, and it also has a mobile component too, so you can actually install a variation of Couchbase on mobile devices like Android and iOS. And then you can use the sync management component called Sync Gateway, which I'll share at the later end of this presentation, for synchronizing your mobile devices with Couchbase Server and then to other mobile devices. So when is NoSQL a good fit in your application? So I like to think of it kind of like this. So if you're building a modern web, mobile, or IoT project, NoSQL is a good fit, because chances are you're going to be building an application that needs to scale. It's going to have, nowadays we have millions of users accessing the internet and accessing these web applications, and you need to be able to accommodate data change at any given time. So it needs to be easy. So if you need to add more different data components to your application, it needs to be easy to do that. Some scenarios where a relational database might still fit, well, maybe you need full ACID support. This is something that NoSQL generally doesn't do. Maybe you have transaction-heavy applications. Maybe your application is legacy. Relational databases are fair game, and NoSQL will probably never replace relational databases. There's always going to be a need for both. You really just have to pick the database based on the needs of your application. In terms of Couchbase in particular, so you're able to develop with agility. So you're able to develop faster and easier with the SDKs available for Couchbase. You have the flexible data model, so you're going to be working with JSON instead of tables and columns and all kinds of constraints. You have powerful querying options, so there's a variety of ways that you can query your NoSQL data. I'm going to go over a few of them. One of them being a SQL-like query language. So you will be able to query with SQL against this NoSQL database. Couchbase has big data integration, and then of course mobile and IoT. So recently I was working on an IoT project. I actually picked up an Intel IoT gateway device. Anyone familiar with that? A little bit? All right. Yeah, I actually picked up one of those devices. I created this Java application. I embedded Couchbase into it, and I used it to collect data about iBeacons. So I had this IoT device, and it was able to scan for iBeacons wherever they may be and collect that information and synchronize it back up to Couchbase Server. So it was a pretty cool project. It wasn't too difficult to do. It's on GitHub. I could share it later. So Couchbase allows you to operate at any scale. So unlike databases like Oracle or MySQL, where you scale up and you add specs to your server, so you add more RAM, more CPU, you're actually working with a horizontally distributed database, so you're adding nodes to a cluster. So if you need more server resources, you add more nodes. You have consistently high performance and always on availability. So when you need to add more nodes to your cluster, instead of having to take your server offline in order to do an upgrade, just go ahead and add a new node and it can remain online. Same if you want to go in the other direction. You're more than welcome to remove nodes from the cluster. So maybe once a year you have high peak season. Maybe you're an e-commerce application and it's Black Friday. You need to add a bunch of nodes to your server to accommodate the load, and then maybe you remove them when holiday season is over to save some money. It's perfectly acceptable, something that you probably can't do with a relational database. There's multi-data center replication and deployment options with Couchbase. You have a simplified administration dashboard, so you could view your data, you can view analytic information about your Couchbase nodes, a whole lot of other stuff which I'll show you soon through this dashboard. And then, of course, there's enterprise-grade security. In terms of Couchbase as a developer, so you have the ability to use many different programming technologies. So you can use, of course, in this one, we're going to use Java. You can use Python, you can use Go, you can use Node.js. Pretty much every popular major language out there, there's an SDK for Couchbase. It's not framework specific. So, for example, in this today, we're going to be using Spring Boot as our Java framework. But maybe you want to use Ratpack, maybe you want to use something else. It's perfectly acceptable. Maybe you're using it like Node.js. You could use Express. You could use Sails. So it's not specific to any particular framework, and it's not specific to any particular operating system either. So you can install it on Debian Linux. You can install it on CentOS. You could install it on Windows, Mac. You even have the opportunity, since it's a software, not a service, you could install it using any of the popular services like Amazon AWS. You can use Docker. You can use any of those popular services. It's perfectly fair game. In terms of Couchbase and its big data abilities, anyone use any big data tools? Spark, Hadoop, Elasticsearch? Yeah, there's so Couchbase has a lot of connectors for it. I particularly use Apache Spark because I find it pretty cool. It's pretty fast for processing data. But there's a variety of connectors available, so you can use Couchbase with these big data tools. You can also use Couchbase with business intelligence tools. So Couchbase has a JDBC driver and ODBC driver. So if you wanted to use Tableau or Informatica, Microsoft Excel, you can still use Couchbase with it. And that's because you're allowed to do SQL-like queries. So nowadays, everyone plays the role of DevOps. It's kind of hard to just be a developer and never touch a database from an operational level. So the good thing about Couchbase is every node that you spin up of Couchbase is going to be exactly the same. So you don't have to do any independent configurations through a terminal or anything like that. You spin up a node, it's going to be exactly the same. And every node is going to have a data service, it's going to have an indexing service, and it's going to have a query service. It's also going to have a cluster manager. So you can scale each one of these services separately. So maybe you're spinning up this node and it doesn't need to be you don't want it to be a query node. Maybe you just want it to be a data node. So you would click a checkbox on the setup, and boom, you have a data service. So it's all maintained within the setup. More in terms of the administration dashboard, and I'll give you a live walkthrough soon. But you handle all of your upgrades through there. So if you need to add a new node to your cluster, you would do that through the dashboard. If you want to know what kind of load each one of your nodes is experiencing, you can view it through the dashboard. There's a querying tool that you can use, kind of like Oracle SQL Developer, that you can use through this dashboard. And then it has its own RESTful endpoints as well, so that way you could interact with it through REST. So I'm sorry, I think that's pretty small on the back, but so in terms of the power of JSON here, so there's different ways that you can store your data in Couchbase, but it's going to be JSON in the end. So for example, one way, if we look at the left here, we have 3 different relational database tables. But let's say that these 3 tables, they're never going to be accessed alone. So if you ever want to look up user skills, you're always going to be accessing users and user experience with it. So instead of doing a join or doing some crazy query, why not just store all of that information in a single document, make it a lot easier to obtain, and it's just one request. You could store it that way, or if you want to go and split it up like the relational tables, you can create a new Couchbase document for each one of those tables. So maybe you create a users document that contains that information, and so on and so forth. And then you could refer to those documents in the same fashion that you would a relational database. But you wouldn't have the same constraints because there are no constraints, but you'd manage that through your application layer. So there's plenty of other ways that you can store this data. It's up to you and the application needs. in terms of querying this data, one way that you can query this data is you can do a key value lookup. So you would provide it a key and you'd get the value back. In this scenario, it's very fast. It's one operation, a direct lookup. You have the opportunity to create MapReduce view queries. Anyone familiar with MapReduce? Anyone who touches the big data stuff, right? Yeah, so you can use these MapReduce queries. You would create this function. It'd be your map function. You would define some logic. It would create an index, and then you can query on that index. Or you could do some aggregation logic through a reduce function. So that's one way. And then there's my favorite, because I actually come from a relational database world. I used to do a lot of Oracle stuff. You can actually use what's called nickel and nickel queries, which are actually SQL-like queries against this JSON database. So you have everything that you would normally have in SQL, but then you have a bunch of other stuff that's more specific to JSON because JSON's complex. It's my preference. You can use any of these three. It's perfectly acceptable. So now more on the developer-y stuff. So we have a background on what Couchbase is, a little overview. Now let's jump into some coding. So in terms of the Java SDK, you actually have the ability to do synchronous and asynchronous things. So I'm going to focus primarily on the synchronous side of things first, and then we're going to merge into the asynchronous stuff. So again, it's not specific to any framework. We're going to be using Spring Boot here because I figured it's easiest to understand for all skill levels. And then there's minimal coding. And since many of you do have relational database experience, this will sound a little familiar, but for anyone who's worked with Mongo or Cassandra, this will probably seem a lot easier. So from a minimal coding perspective, when it comes to NoSQL, you don't have to manage any schema. So with a relational database, if your data changes tomorrow, you would have to write these upgrade scripts and accommodate all of this data change. With NoSQL, you want to add a new property to your documents, just add that property, and you don't need to worry about anything else. So you don't have to write all this code to manage that. The other aspect of this is there's no parsing your queries application side. I mean, you could if you wanted to, but you could run this SQL-like query, have the server parse all of this data, return back exactly what you want, reduces your application code. Nothing new for people who work with a relational database, but if you've ever worked with Mongo and their query language, you end up with a lot of application side parsing. So here's what it would take to get it up and running in one of your Java applications. So first, what you would do is you would connect to a Couchbase cluster. So you would provide it an IP. You can actually provide it a list of IPs if you wanted to. Once you connect to one of these nodes in the server, the SDK receives what's called a cluster map, and all nodes in the cluster are peer-to-peer, so you would now have information on all of these nodes. But you'd probably want to add more than one node to this list in case maybe that one node is down when you're trying to connect to it. It's up to you and your application needs. After you have a connection to the cluster, what you would do is you would open up a particular bucket on that cluster. In this case, I'm opening custom bucket, and the password is going to be password. So a bucket is actually a collection of NoSQL documents. Usually you would have one bucket per one application, and that one bucket could contain many different types of documents. You don't have to do it this way. You could create as many buckets as you want. There's 10. You're allowed to have 10 per cluster, but it really depends on what your needs are. Once you have this open bucket, we can now create a document. So let's say we create this document. We're creating a JSON object. This JSON object class is part of the Couchbase SDK. It's pretty much the same class that you would find in the Apache JSON object class, or there's a few other ones that are pretty much the same as well. So you would create this JSON object. In this scenario, we have one property called name, and its value is John. Then we would create a JSON document. We would define a key for that JSON document, and then provide the JSON object as the value. You could model your keys however you want. They could be something that you can remember, like key 1. They could be some unique identifier. They could be some kind of incrementing value. It's up to you. But once you create this document, you can call bucket.insert, and it's saved to Couchbase. So now let's say we want to get a little more complex with things. And I realize it's a little small probably in the back. But let's say we have this function. This function,
Can we turn the lights off on the front?
I don't know.
No, there's no way to do that. There's only one switch and it turns off and on.
Oh, nice.
All right.
No? All right. Yeah, so we have this function here. In this case, I'm calling it function. We're returning a list of maps. So list of maps is going to be JSON data for Spring Boot. And what we're doing is we want to run a query. We're running this nickel query. We're saying select all properties from all documents that exist in this particular bucket. Couchbase doesn't understand strings, so what you do is you take that string query, you convert it into a nickel query, and then you can run bucket.query and get your result set. Right now we're still doing everything synchronously, so we're waiting for that response. If that response is some kind of error, we're going to return that an error had occurred. Otherwise, we're going to create a new list of maps, and we are going to add each result in that result set to this list of maps. And then we can return it to whatever function has called it. Here's something a little more complex. In this case, we're doing a union here. We're unioning two data sets together. What we're also doing is you'll notice that the $1 and $2 exist. So we're doing a parameterized query because just like relational database, NoSQL can suffer from injection attacks as well. So we run this parameterized query. The JSON array is each parameter in order. So in this case, we're doing a from and a to value, which are strings. We run this query, and let's say that extract result or throw is the function right here from the previous slide. I've just reduced my code a little bit, so let's just assume it's that. So I do have a demo. I'm going to show you the demo so that way you get an idea of what the next code is going to look like, because the code is going to be based around this short demo. And I'll zoom out. Still visible? Yeah? All right, so this is probably the most basic demo you'll ever see. It's common for when you're learning a new technology. It's just a record-keeping app. You can add new items, or in this case, people, to the list. You can edit those people. You can delete those people. So the full deal. So in this case, I'll run through it. You probably already have a visual of what it does, but I'll run it through it anyways. So I'll add another one. Oh, that's because I am not running the application. Let's start over. All right. All right, I saved it. I'm not doing any particular sort, so just add it to the top of the list, but I've added a new person to this list. Now let's say I want to edit. So I click edit. I know it's small in the back, but I actually have the document key in the URL bar. It's not even visible on the screen. Let's just assume that the document key is up there. That's how I'm pre-populating this form. But let's say I want to use my short name here and save, and it's saved. So then finally, let's say I want to do a delete. Maria's deleted from the list, and now I'm left with one. So if I go to my Couchbase administration dashboard, so let's see if I can zoom out a bit. Visible? All right, so this is what you would get when you log into Couchbase. In this case, I want to go to data buckets. I want to click, I'm inside of the RESTful sample data bucket. And if I click on this document, this is the information that I've saved for that one particular person that exists in the database. So let's look at some more slides here. So that application was actually split into two parts. All of the front end that you saw was built with AngularJS, JavaScript, CSS, HTML. just anything that you would normally find in a front-end framework, front-end stack. The back end was all Java, all Couchbase. And why did I choose to separate the two? Well, it gives you a more API-driven approach. You're no longer piping in data from the database to your front end. Instead, you're making HTTP requests against your back end from your front end. It allows separation between your client and your server, so that way maybe either of the two sides needs to evolve down the line. So maybe your back end needs to have some significant changes, but the data is going to be the same on the front end. You won't need to take it offline, whatever the scenario may be. It also allows you to extend your front end. So maybe you have your AngularJS web front end, but then you want to extend this to mobile as well. Well, you already have your API backend. You just need to create another front end that can communicate with this API. Or maybe AngularJS one day croaks and it doesn't exist anymore, and you want to switch it to React. You can switch it, and the backend won't need to be changed. Here's an example. I can't say that this is a real example, but it's what I would assume. But let's say the game consoles out there, like let's say Xbox. So let's say I can purchase games on my phone, my console, my web browser. I can only assume that those are just 3 front ends that are communicating to this backend API that does all of the API and database work. So let's look at the code for the backend. Again, this is a Spring Boot application, so Spring Boot application will have an application properties file. In it, I'm defining the connection information for my server. In this case, it's running locally on my laptop. And the bucket, of course, is RESTful sample, and it doesn't have a password in this case. As far as my endpoints go, so when my AngularJS application makes the HTTP request, it's going to hit these endpoints first. It's not going to do any communication with my database yet. So when it hits this endpoint for save, it's going to be a post request, and we're going to be sending a JSON body with it. So it's going to be a string. So we're going to take that JSON body, we're going to parse it into a JSON object, and we're going to look at the properties in that JSON object. So we're going to say, does this JSON object have a first name property? If it doesn't, return an error because it needs to have a first name property. Likewise for last name and email address. If all of those 3 conditions pass, then we can call this database.save function, which we'll see in like 3 slides from now, and where the actual saving will occur. Here's another endpoint. So this one would be, say I want to get a document. So say when I click on the edit button and it pre-populates that form, this is the endpoint that would be hit to get the data for that document. So it'd be a GET request. We're expecting that we're passing in a document ID. Doesn't exist, throw an error. Otherwise, let's call this get by document ID function. And you can see a trend here. All of my endpoint functions are pretty much the same. They're just doing a whole lot of validation of my data that's coming in from the client front end. So in this case, delete. Here I'm doing a post request. It should probably be a delete request. For me, it doesn't really matter. But let's say we're passing in a post body again. We're looking to make sure the document ID exists. If not, throw an error. Otherwise, call this delete function. So now we'll move on to this database class. But first, here's that extract result or throw. I told you about it previously. This is just a refresher that all it's doing is it's taking those results and it's converting it into a list of maps. So here's the first database function here for saving. So the first line here, well, first we're passing in the open bucket and we're passing in that JSON object. The first line here, string document ID, it's a ternary operation. What we're saying is if a document ID exists in this JSON object, let's go ahead and use it. If it doesn't exist, that's fine. We'll just create a unique value for it. So document ID was an optional parameter that we're not validating for. The reason why we're doing this ternary operation here is because we want to hit 2 birds with 1 stone here. We want to do a create or we want to do an update. So what we're actually doing is called an upsert. which will do exactly that. It'll create a document if it doesn't exist, if the key doesn't exist, or it will replace it. So we're doing this upsert. You'll notice that we have the parameters in there because we're doing a parameterized query. We're passing in each of these values in the array in order, and then we're executing the query and we're returning the results back to the endpoint that called it, and then that endpoint will return it back to the AngularJS layer. Feel free to stop me if you have questions, because I'm happy to stop. This you've seen it already, but this is what it would look like in Couchbase after you save it. Here's another endpoint. Let's say that this is for getting a oh yes.
Okay, you were using all the JSON objects, like you're using JSON object itself. Is there a way like we can serialize it from Pojo? Does it support that, or we need to build some infrastructure?
So there's Pojo stuff in the works. It's not, to my knowledge, it's not complete yet.
Okay.
But yeah, if that's your preference, I can get more information for you on that one. All right, yeah, this is the get function. So in this case, we're doing a select statement, typical SQL here. We're selecting the first name, last name, and email from this particular open bucket. We're aliasing it as email as users, and then so we're not actually storing the document ID in the document itself. We could, we don't have to. Instead, what we're doing here is, well, we need to look at that document ID, so it actually exists in the meta information about the document. So you can use the meta function to get that document ID, and then we're comparing it against that parameter, the document ID parameter. We're creating our parameterized query, passing in the document ID, running the query, returning the results. Nothing new here. And you could probably predict that the next slide is like exactly the same, except for it's a delete. So all of my endpoints are doing validations. All of my database class functions are just working with the database. They're all very similar in how they're structured. Many different ways to do this. This is just my preference on doing things. Makes it very easy to maintain in the long run. Now let's look at some of the AngularJS front end. Anyone have any questions on the back end so far? No? So this is an AngularJS function that I didn't show you an endpoint for. It exists, but it's very short. But let's say this AngularJS function communicates with the getAll endpoint. So with AngularJS, this is AngularJS 1, not 2, which is still in release candidate right now. It actually has an HTTP service, so we can use that HTTP service to make requests. In this case, we're doing a GET request against this getAll endpoint, and then it'll actually hit that endpoint, and then if the response is successful, it'll loop through the results, and it will add them to the application scope, which can be rendered to the screen. Here's a more familiar endpoint. This is for saving a document. So in this case, we're using the HTTP service again. We're making a post request, and we're hitting this save API endpoint. For data is actually going to represent our post body. So we're passing in a first name, a last name, an email, and then that optional document ID. If that document ID doesn't exist, if it's null, that's fine because our backend is going to handle that. It's going to create an ID if it doesn't exist. The rest of the Angular functions are pretty much the same as this. So I'll skip over those and go briefly on the asynchronous part of the Couchbase SDK. So the cluster and the buckets have a method called async, and it allows you to expose RxJava observables. Anyone familiar with RxJava? Only a little bit? All right. So with RxJava, all right. All right. So with RxJava observables, you can do different operations on them. You can do transformations, you can do combinations, filtering, various cool things like that. So for example, here we have an RxJava call here. So the first thing that we're doing is we're calling async, and we're getting a particular document based on its key. This document is going to have a key called key1. By default, it's going to return an observable of type JSON document. And then observables are streams of data that you can monitor. So with that stream, with that, what we can do is we can call map. So maybe JSON document is pretty useless to us. It's not something that we want to work with. So what we would do is we would call map, and we would convert it to a new data type. So in this case, we're doing a transformation to convert JSON document to type string. So in this case, once we make this map, the value that we have is now going to be this name property. And then when we subscribe, when we get a notification of this event, we're just going to print out name, and that's what we're going to be left with. So you can do this whole flow, and it makes, depending on the scenario, it makes life a lot easier, and there's certain conveniences about it, but it's ultimately the needs of your application. It's synchronous. I use synchronous all the time as well. So I'm going to take a turn here and talk about mobile, because Android is Java, so figured it makes sense to talk about mobile here, Android in particular. So Couchbase Mobile is composed of 3 components. We already heard about Couchbase Server, but now let's hear about Couchbase Lite and Couchbase Sync Gateway. So Couchbase Lite is the embedded database. You can embed it on Android, iOS, you could embed it on IoT devices, you could even make desktop applications out of it. Then there's Sync Gateway, which handles all of the synchronization between the two. So again, Couchbase Lite is a full-featured, lightweight NoSQL database. I mentioned that it works for Android and iOS. It's not limited to those two. You can use it Apache Cordova apps, Unity apps, Xamarin. It's all over the board on what you can use it with. And then Sync Gateway handles all of the synchronization. It also handles all of the authentication. So chances are everyone who uses your application, you probably don't want them to have all of the data that exists in your database. So you would set up these partitioning rules and authentication read-write access rules and define who exactly can access what data.
So you would have to make this part of your app when you're developing like an Android app, for example. You import that API or import that tool into your application?
Good question, but sort of.
Okay.
So you have Couchbase Lite. That gets embedded into your application. It's a replacement to SQLite. So you have this, now you're working with NoSQL in your application. Then you have Sync Gateway, which has its own configuration file. And inside of this configuration file, you would define all of your read and write rules, all of the authentication rules, and then your application, whether that be Android, iOS, whatever, would try to connect to Sync Gateway. Sync Gateway is a server-side application. Again, all of this is open source, so you're free to check it out. Does that answer your question?
Yeah, it does.
All right, and I'll show you some examples. And then, of course, there's Couchbase Server, which we've already heard about. So a little more on Couchbase Lite. So it's a NoSQL embedded database. It runs in process, so when you embed it in your application, you start your application, it starts its own little server. This is particularly convenient if you wanted to do peer-to-peer. So maybe you want to cut Sync Gateway completely out of the picture. You can have it expose the URL to this server, then you could consume it on a different device, and you could pull data and push data depending on how you've configured it. Couchbase Lite has a small footprint, so it's about 40 kilobytes in size. No, not 40, 400, sorry, which is still pretty small. It's not adding 20 megs to your app, so no worries there.
Is there a limit to how much data you can put?
No, but you probably want to be conservative on that. So that's where the partitioning comes in with your data. So for example, let's say you're making an Amazon app, and somebody's trying to browse for garden equipment. Chances are you don't want to download all of the cooking equipment with that. So you would download the partition that you've defined of gardening equipment, which is X amount in size, but at least you're not downloading everything from Amazon in this process. So you're keeping it somewhat, I mean, you would define these rules however makes sense to you. In order to use Couchbase Lite, we're talking about Couchbase Lite right here in your Android application. So you'd get the Android context. Let me step back. Anyone develop Android applications? Or is this a first?
A while ago.
While ago, all right. Well, if you know Java, it's not too bad. So you'd get that context, then you would create this Couchbase manager object. With that manager object, you can then get a particular local database. So in this case, it's kitchen sink. That database doesn't exist. It'll create one for you and then get it. Once we have this open database, let's say we want to insert a new document into this database. So you're not doing an insert query anymore. You're adding a new map. So your map is your document. In this case, one of our properties is going to be foo, and the value is going to be bar. The value could be an array list. It could be whatever you want. That's the beauty of NoSQL. So you can add whatever data type you want there. Once you have your data defined, you can call create document. It'll prepare a document for you, and then when you call put properties, it's saved. It's saved locally. So this is all local right now. When it comes to querying your data in Couchbase Lite on your Android application or iOS or whatever, you'd use MapReduce indexes. So this is also available for Couchbase Server, like I mentioned. But in terms of Android in particular, so you'd be creating these MapReduce views with Java. With iOS, you do Objective-C. Couchbase Server, you do JavaScript. You do whatever language it is that you're using. The results are persisted for very fast querying. And it's because these are functions, you could add your own breakpoint and troubleshooting logic. So I'll show you right now. So this is a sample. This is a MapReduce view for Android. So in this case, we're creating a view called items by date. And then we have our map function here. So inside of our map function, we're saying we want to look at these documents and see if a property called created at exists. So it's not null. If that condition is met, we're going to emit a key value pair of information. So in this case, we're emitting the actual created at timestamp, and the value is going to be null. When I develop Android applications, what I'm doing is the key is actually going to be my document ID, and the value is going to be the document itself, so that way I can do whatever manipulations I want inside of my application. But it's completely up to you what you want to return there. Once you have your view created, you could create a query. You can you could add certain features to it. You could say you want to sort it in descending order. Maybe you want to limit it to 10 results. You can do further stuff on your query, and then you would run it. When it comes to looking for data changes, you don't need to continuously query for changes. Instead, you could actually listen for changes. And that actually cuts down a lot of cruft code because you're not creating your own timers. You're not doing all of this query logic to see if maybe one document has changed in your database. You're listening for those changes, and then you can update your UI appropriately. And these listeners, you can create listeners on the whole database. So maybe any document in the database has changed. You could listen for changes on a particular query, narrow it down. You can even see if a particular document has changed. This is what a change listener would look like if you wanted to code it for Android. So in this case, this would be a change listener on a particular document. And inside that listener, let's say we want to check to see if there was a conflict. So when you're working with mobile and Couchbase Mobile, you have to assume that you could have any number of people try to edit the same document at the same time. There may be conflicts. So you can actually check to see if there was a conflict and then run your business logic to determine what you want to do, which change do you want to keep, so on and so forth. You can also check to see if maybe the document was deleted, so that way you can remove it from maybe a list view or whatever it may be. Yes?
Just you mentioned delete. Is there a way to maybe expire the data as well? Are you going to talk a little about that, or?
I wasn't going to talk about it, but yes, you can set data to be expired. And then because of this conflict management, you are also left with revisions. So it keeps track of several revisions, so that way you can roll back to a different save in the event of a conflict, or maybe in any event. So in terms of sync gateway, so you can actually do full multi-master replication. You can actually design it so that way you can minimize your battery drain, and I'll show that in the next slide. And then as well, there's conflict detection and change notifications. So up until now, I've only shown you local stuff, nothing to do with synchronization as far as code goes. So if you wanted to start synchronizing with Sync Gateway, this is all the code that you would need, even less if you really wanted to. So in this case, we're saying I want to do pull replications from a particular Sync Gateway URL. I also want to do push replications. I don't have to do both. I can do one or the other. I can do both. It's up to you. Maybe your application, maybe you only ever need to download data. There's scenarios for that. I talked about battery drain, so you can set continuous replication. You probably don't want to do that in most scenarios, because if you're continuously synchronizing, your battery is draining all the time. So, I mean, there's scenarios where you would need to, but more often than not, you might have a pull to refresh, and then it would start synchronizing. Maybe you want to synchronize only when your application opens. You can do it one time, or you can do it continuous. Then you would set your authentication. So in this case, we're doing basic username and password authentication. You don't have to have any authentication at all if you don't want to. Or you could do maybe Facebook auth, persona. There's a lot of different options here. So you would define your authentication. In this case, the next two lines we have, we're setting up our change listener. I generally don't use a change listener on my replicators. Did you have a question?
No, I was thinking.
Oh, all right. Yeah, I don't generally use change listeners on the replicators themselves. More, I listen for changes on the data. But I can see where it would be useful. Maybe you want to be notified when a synchronization process starts or stops, whatever it may be. And then when you're finally ready, you call start, and that's all it takes to synchronize. Of course, I didn't show you the configuration to Sync Gateway, but from a Android level, from a client device level, this is all the code that you would need. And it handles all of the edge cases for you when it comes to conflicts, all of that good stuff. And it also, has anyone heard of offline first? So offline first is a concept where your app is going to be usable, your data is going to be accessible whether you're online or offline. So there's a lot of apps out in the App Store where the only way to get the data is through REST. And if there's no internet connection, you're not going to get the data. With offline first, you're always looking at this local database. This local database will always exist, and it'll always synchronize. So if your internet is gone, who cares, because you've got a local copy of it. So that's the offline first approach. And I like to think of it as better, because then your app will always work under all scenarios. But it's a good concept. In terms of how do you get Couchbase Lite for Android, so you can use JCenter. You can use Maven Central, Couchbase.com, and GitHub. You would typically add these to your Android Gradle file, or maybe you're using Ant or Maven, whatever your build files are that you're using. Yeah, Ant is old. I think the norm now is Gradle, but I think people still use Ant. I do have a mobile demo, so let me boot up some simulators here. Just be a second. I'm actually booting up two Android simulators, because this is an Android application only that I developed. So there will be no iOS in this example. All right. And let me start Sync Gateway.
Quick question.
Yes.
You don't run into any storage problems using a local database?
Well, you would have to be considerate of your users. You'd have to define this business logic somewhere so that way it doesn't take up all of your storage space.
Is it using flash or is it using RAM?
So it's persistent. It's not going to be in RAM. Yeah.
Oh, it's in flash.
Yeah. Okay, so I just started Couchbase Sync Gateway. And I'll show you it does have its own dashboard. So I did start it. The database I'll be using is called To-Dos. There's nothing in it right now. So let me get a new terminal going. I'm just installing it to my two simulators because I don't already have it installed. Alright, so the same app is installed on two different simulators. They're running two different versions of Android. I have Sync Gateway running. Let's go ahead and see if we can make this work out. So I'll add a new to-do item. It's a little slow because I've got like a million things running on my computer right now. This is all local on my machine right now. What was that? Yeah, it's synced. It's a lot faster when it's not this. But it did sync. Now if I go back to the dashboard here, it did save. This save that I did only has one property. The revision in the ID is part of what Couchbase Lite does. And then I didn't mention this, but Sync Gateway on my laptop right here, it's not connected to Couchbase Server. I'm just prototyping, so I'm using an in-memory database. So when I shut down Sync Gateway, my data will be gone, and that's all right in my case because I'm just prototyping. Let me go ahead and add another item here to this other simulator. All right, so it's synchronized over, and it is there. I don't have a UI capable of changing the data, so what I'm going to do is I'm going to simulate a change inside of the Sync Gateway. So I'm going to say, instead of clean house, I'm going to say clean apartment, and click Save. The revision did increase, and it did change inside of the app, which I realize is hard to see. It did change to clean apartment. And then finally, I do have a delete. So I'll delete it, and it's deleted from both simulators. So the code that powers this application is near identical to what I showed you on the slides. So there wasn't a whole lot to it. Anyone have any questions on this? So I'll just give a recap here. Couchbase, all of it is open source. Takes a few minutes to get set up with. It's NoSQL database all around for mobile server. You get sync involved. You can use SQL-like queries. There's a whole lot of great stuff that you can do with Couchbase, and it's really easy to use, as seen on my. Hopefully, my slides were easy as far as what I was doing. I do have a table here. I won't go over it, but I will share the slides. So everyone can go over it on their own, but this is a comparison table of Couchbase versus other NoSQL databases. And then if you wanted to check out any of the projects that I showed you, so the first one, the very simple Angular Java example found on GitHub here, the first link. Second link I didn't show you on, but it's a more complex Angular JS and Java example. And then, of course, mini hacks will be a bunch of mobile stuff that you can look at. Was that?
I was going to ask a question.
Go ahead.
So all the components that you showed us, all free and open source? And
There's a community edition and an enterprise edition. So the Community Edition, you can use it however you want. You could take it to production. You don't have to pay anything. Enterprise Edition has a few more features, definitely tailored towards enterprises. That one, there are licensing involved.
Is that also on the mobile side too?
Correct.
So in that case, would like the enterprise have like a replication where your what's the limitations?
Yeah, so
is it open? Does it
there-
just your point to one server?
No. So you get all of the clustering and replication features in Community Edition. Where things start to change, with Enterprise Edition, you get cross data center replication.
Okay.
You get certain things like multi-dimensional scaling. You get more encryption features. So you get LDAP. You get stuff like that. You get stuff that enterprises would expect.
Okay.
Does that answer your question?
Yeah.
All right. Where do you find help? Well, you could use developer.couchbase.com for documentation. I actually write a lot of technical articles on blog.couchbase. You can reach out on Twitter. Either of these Twitter handles. You can even reach out to me personally on Twitter. I'm at nraboy. Or you can visit the forums or Stack Overflow for help. That is actually all I have.
Something that I've noticed is that there's a lot of the cloud platforms
Sure.
have hosted Couchbase.
Yeah, so I mean, Amazon is a popular one.
Like Compose is one, I guess. I think.
I'm not
Is that
familiar with that one.
Couchbase or is that?
I'm not familiar with Compose.
Okay. Maybe that's something that might be something within Lumix, IBM's Lumix.
Oh, are you looking at their cloud stuff?
Yeah, cloud.
Yeah.
It's cloud.
Yeah.
There is cloud put down there. I may be confusing because I know that
Maybe.
I know that there's like Heroku. You have several options.
Oh yeah, there's too many options to list.
Yeah.
Yes.
I have several questions.
All right.
The NoQL which you showed,
Uh,
NQL or
yeah,
NoQL,
Nickel
that's only for Couchbase or it's common for all?
only for Couchbase. So it's I mean, relational databases have SQL, but as far as NoSQL goes, that's probably going to be the only thing you find for NoSQL that's like that.
Okay. And can I save XML documents?
You can. It's JSON or binary data.
Can I do XPath lookup style lookup in the documents, JSON documents? Is there a way, if I want to look for some documents which has got a particular attribute value, can I do that if it is not indexed?
If it's not indexed, it would need to be indexed.
It need to be indexed. Can the documents be indexed after storing into the document store? So suppose if I have 50,000 documents stored and then I realize, oh, I didn't create this index. Can I go ahead
Yeah, absolutely.
and create that index?
Yeah.
And if I have multiple nodes in my cluster, would that index be automatically replicated on all and
So-
I would be able to?
Yeah, it depends on what kind of index you created.
That,
Oh.
so sorry. The tool that he's talking about, that takes the data and converts it to a list of maps. I know you guys said, you were saying that in the future, you guys might move to POJOs. Because I'm kind of wondering what the speed difference is between using something like Jackson to deserialize an object versus using the tools that you guys have to
Yeah,
convert
I
JSON.
I don't have any information on that one. Sorry.
That's
In the back, I thought there was a question.
Yeah, what are the data formats outside JSON have you seen getting used on Couchbase?
I've only seen JSON and binary data for attachments. So like with Android, often people might want to upload a photo. I mean, they're not going to convert that into some kind of weird JSON format. They're going to store it as a binary document and upload that. But beyond that, nothing.
So if you, okay.
No, you go ahead. Something else.
So if you do have something like, if you do have to store something that's not JSON, but is also text, I guess the recommended strategy would be to convert it to some kind of JSON, or can you kind of wrap text within some kind of wrapper and then store it as a
That's not text, or
I'm sorry, it is text. Let's say an XML file.
Yeah.
Would you then either convert it to JSON, or would you have, is there some kind of wrapper that you
I
can
mean,
kind of,
if you wrapped it, you would lose a lot of the core features of being able to query it.
but if you just wanted to shove it in there, those
Yeah, you could serialize it, but yeah,
Like a
at that point it
blob.
would just be a key value lookup.
object with the field that's actually it's XML.
Yeah,
You can do
it'd just be more key value like.
I was gonna ask, when you were showing like where, you know, I'm on a mobile device and I'm syncing up
Yeah.
between the two, is there a way where, say like everything would be synced up, would there be a way to, like, a user goes in and they for your example, they say, I wanna add these 5 items from the garden to my wish list.
Yes.
Okay, those are the only things I want to sync up. Or maybe they highlight several, but I only want a subset of those things to be synced up. Is there a way to control that when you're updating back to the host?
Yeah, so I mean, you would do all of this through the configuration file of Sync Gateway. You can customize those, the data partitioning however you want. In your scenario, you'd have some pretty refined business logic probably, but the synchronization will only happen based on that criteria. So maybe you're only wanting to synchronize documents that contain a property called garden, and then they get synchronized to this garden channel. You could do that, but it's really how creative you want to be when you
Okay.
define this stuff.
Cool.
Yes.
When you add multiple nodes to the cluster, does each node have replication of the data, or it is partitioned data?
So you would configure this. So when you add new nodes to your cluster, you would do what's called a rebalance, and that will disperse all of the data equally across your cluster. So that way, not any one node is having more data on it than another. You also can define how many replications you want. You can have up to 3 replications. So if you enable 1 replication, your data will be copied at least 1 time around the cluster. So that way, if your primary active node goes down and it has that data on it, the other node can take its place with that data in a failover situation. Does that answer?
Is it up to 3?
Up to 3.
Is there more for the enterprise version?
No. I mean, so let's say, would you really need more than 3? I mean, more than that, you would generally be doing some kind of snapshot backups as well in an enterprise situation. You wouldn't completely rely on replication data. I can't think of anyone who's said that they've needed more than 3.
You talked about data center
Yeah.
application. Is it 3 in each data center, and so it just, you would technically get 6 copies
Yeah, I
in
think
that case? Is that?
Yeah.
Is that what it does?
that sounds accurate.
That does with the help of Sync Master or without?
So replication with Couchbase Server there's no Sync Gateway involved in that. I mean, you can still set up your own clustering of Sync Gateway, but since it's multi-master replication, I mean, they're not. You just attach it to one and they'll receive the same data because it doesn't actually store the data. They're all connected to the same clusters. Thanks.
Okay.